Hello students. So today we will discuss all the properties of definite integration present in NCERT class 12th book. Okay. So as I already have written the properties of definite integral, so let's discuss one by one. So property number first P0. P0 property says that sine of integration a to b fx dx same as sine of integration a to b ft dt. So it means that your definite integration is independent of the variable, independent of the variable. Definite integral never depend upon the variable. Anytime you can change the variable from x to t or u or v or w, whatever you like. So this is your p0 property or p0 property. Next property p1. So according to this property, if there is an integral from a to b fx dx, so if you interchange the limit, from a to b and you will write b to a, then you have to put one negative sign in front of the integral. So this is your p1 property. Property number 3, that is p2 property. So according to p2 property, if your integral is a to b fx dx, then it can be written as a to c fx dx plus c to b fx dx. And where we will use this property? Usually be used in mod function, absolute value function. So for example, if you are having 0 to 3 mod x minus 2 dx, then it can be written as, by using this mod property, your function is breaking at 2, so you can also write 0 to 2 mod x minus 2 dx plus 2 to 3 mod x minus 2 dx. And then using the properties of the mod function, you can evaluate this integral. Okay. Next property p3. This is very important. p3, integral a to b fx dx can also be written as integral a to b f of a plus b minus x. It means you can replace this. It means you can replace x, y, a plus b minus x, and your integral will not be changed. Okay. Usually we call this property is king property. In competitive, we call this property is king property. It is very useful. Next, p4. According to p4, 0 to a fx dx is same as 0 to a f of a minus x dx. This is also a king property. इसको भी king बोलते हैं. Actually, this is a particular case. This p4 property is a particular case of p3. Okay, particular case of p3. Next, p5. According to p5, your integral 0 to 2a fx dx, it can be written as 0 to a fx dx plus 0 to a f of 2a minus x dx. Okay, it is also sometimes helpful. Next, p6. According to p6, if your integral 0 to 2a fx dx, then this also important. And if you remember, we have covered in one video the most difficult integral. If you remember, 0 to pi by 2 log sin x dx, its value came minus pi by 2 log 2. So to prove this integral, we will take help of this property, p6 property. You can refer the video. I will put this video on the I link. Okay. And it says that according to this property, if f of 2a minus x is fx, that time your integral will be 0. Now p7. According to p7, integral minus a to a fx dx to 0 to a fx dx. If your function is an even function, then it will be double of the integral and limit will change from 0 to a. Instead of minus a to a, it would be 0 to a if function is even, and if function is an odd function, then it will be 0. It is also very important property. So many MCQ you will see based on the property p7. For example, if I give you one example, for example, minus 1 to 1 x power 17 sine power 4x dx. What would be value of this integral? Now if you know this property, see, x power 17 is an odd function and sine also is odd function, but sine power 4 which is even, so odd power even is an even function, so ultimately it is odd and even function, so odd into even function again odd function. And according to this property, minus a to a, odd function always 0, so it's this integral would be 0 without solving. That's why it is very important property, mind it. What was p1 property? P1 property was integral a to b fx dx is same as b to a fx dx minus sign. It means if you change the limits, then you have to put negative sign in front of integral. Okay, so prove this. So to prove this, we will use the second fundamental theorem of calculus. So what is that? So according to, just recall second fundamental theorem. So it says that if capital Fx is anti-derivative of small fx, then integral a to b fx dx same as fb minus fa. Okay, fb minus fa, f of upper limit minus f of lower limit, capital F upper limit minus capital F lower limit. Okay, so we will use this property. Now see here, take LHS a to b fx dx. So by second fundamental theorem of calculus, it is same as fb minus fa. Okay, now take minus sign common, then it will be f small a minus f small b. Okay, now again apply the this fundamental theorem, so it would be minus, it will be integral fb minus fa. So now this is upper limit a to, this is a, this is b, fx dx. How? By second fundamental theorem. Okay, and which is your right hand side. Okay, hence proved. Now let's see the property next, which is p2 property. p2, what is p2? P2 says that if sign of integration limit a to b fx dx, then it can be written as a to c fx dx plus c to b fx dx. Okay, this is the property. Okay, so okay, we will prove this, not an issue. Here also we will use the second fundamental theorem of the calculus. Okay, so by second fundamental theorem of the calculus, what is this integral a to b small fx dx? It is same as fb minus fa, no doubt. Let's say question 1. Now if I say what is this integral a to c fx dx, a to c fx dx, so by second fundamental theorem, it would be f of upper limit this time c, fc minus fa. Okay, equation number 2. Similarly, what is this integral? By second fundamental theorem, c to b fx dx is f of upper limit is b this time, fb minus fc, equation number 3. Okay, now do one thing, add equation 2 and 3. Add equation 2 and 3. Okay, so it would be left hand side with left hand side, a to c fx dx plus c to b fx dx equals to right hand side fc minus fa plus fb minus fc. Now you can see fc, fb minus fc. Now you can see fc and fc cancel. So what we are getting? We are getting fb minus fa, and fb minus fa from equation 1 or by using fundamental theorem, it is nothing, it is same as a to b fx dx. Okay, ax dx. So it implies that sine of integral a to b fx dx equals to a to c fx dx plus c to b fx dx, hence proved. Okay, now let's see the next property. Integral a to b fx dx equals to integral a to b f of a plus b minus x dx. Okay, so let's see the proof. Take LHS, left hand side, a to b fx dx. Now here we will do by using method of substitution. So what to substitute? We will get the hint from here. We want to prove a plus b minus x. So here we will use this x equals to a plus b minus t. This substitution. Why we are putting this? Because we want to prove f of a plus b minus x. So we are getting the hint x equals to a plus b minus t. Okay, now differentiate. On differentiating, x derivative dx, a is constant, so 0, b constant 0, and derivative of t is dt. So from here dx equals to minus dt. And you know very well, in the definite integration, when we substitute, limit also changes correspondingly. So what about limit? Limit. See, initially they are limit of x equals to a to x equals to b. Now you tell me, when x equals to a, then what is t? T would be this. From here, you see here, put x value a here. So a equals to a plus b minus t. A and a cancel. So from here t value is b. Similarly, when x limit is b, upper limit, that time t value would be a. You can check. So now your integral changes. Your integral changes like this. This LHS integral limit a to b will be b to a. Okay, corresponding to a, the t value is b. So limits t from b to a f of, and x value we are using a plus b minus t, a plus b minus t, and dx value is minus dt. So this minus I can use here, dt. Next, now you know that property we have proved. So when we interchange the limit, we have to put negative sign. So already here negative. So if I write again, I interchange the limit, b to a given, I will write a to b. So we have to put one minus, and minus one more minus plus f of a plus b minus t dt. How? By using p1 property. Okay, by using p1 property. So it is minus plus a to b f of a plus b minus t and dt. And also the p0 property says that your definite integration is independent of the variable. So it means I can write this a to b f of a plus b minus x dx. How? By using p0 property. Okay, so can you see, we have done the proof LHS, and this is your RHS, hence proved. Okay, now p4. Okay, this p3 and p4 we can treat like king property. Okay, very useful. Later we will discuss on this. So what is p4 property? p4 property says that integral 0 to a fx dx equals to 0 to a f of a minus x dx. Okay, this is very important. When you do the NCERT solutions in the definite integration, 80% times this property you will be using. Okay, so let's see the proof. Again take LHS, 0 to a fx dx. Again this we will prove by using method of substitution. Okay, so put x value, and again what to put here, take the hint from here, a minus x. It means we can put x value is a minus t. Okay, now differentiate. On differentiating dx equals to constant integral, a constant derivative 0, and t is dt. So it will be dx minus dt. So we are using dx value minus dt and x value a minus t. Then corresponding limit will be changed. Okay, limit when x value 0, then t value will be what? Here see, x value 0 equals to a minus t, then t value is a. Okay, and when x value is a, then t value would be 0. So now your left hand side integral would be this: limit 0 to a will reduce to a to 0 f, and x means a minus t, and dx means minus dt. So this minus I will put here. Then again the same process as we have done for p3 property. By p3 property, use p1 property. Interchange the limit 0 to a, then minus minus plus f of a minus t dt. Okay, by using p1 property. Okay, p1 property means a to b fx dx same as minus b to a fx dx. Okay, next. Now we know that by p0 property our integral is independent of the variable, so we can write like this: 0 to a f of a minus x dx. Okay, by using p0. Okay, so which is your RHS, right hand side, hence proved. Now let's prove property number 6, that is p5. What is p5 property? p5 property says that limit 0 to 2a fx dx can be written as 0 to a fx dx plus 0 to a f of 2a minus x dx. Okay, so let's prove this. We will take left hand side LHS 0 to a 0 to 2a fx dx. Okay, here we will use the property number p2. Okay, we can break this integral 0 to a fx dx plus a to 2a fx dx. Okay, by using p2 property. By using p2 property, suppose it is equation number 1. Now you can see we have taken LHS and we want to prove this. If you see this already here, okay, it means no need to do anything with this. Whatever the substitution or any technique, okay, we have to do with this integral. So here we will use one substitution. What we will use? Put x value equals to 2a minus t, and I told you how to get the hint: 2a minus x. So put x value 2a minus t. In previous properties also we have seen this hint. So now differentiate after putting. Then on differentiating, dx will be 2a 0 and t is dt, so dx value minus dt. And what about limit? Limit also will be changed. Limit when x is a. Okay, when x is a, then what is t? What is t? From here, see, when x value is a, then t here, so 2a minus a, that time t value will be a. Now when x value is 2a, then what is t? T is again here 2a minus t, so 2a cancel. Okay, so it means simply it will be 0, then t value is 0. Okay, so now what is the integral after doing this substitution? Okay, and this substitution we are doing in the second integral. Okay, then okay, so what will be this? We have done substitution in a to 2a fx dx, and it reduced like this. Limit becomes a to 0. Okay, and x means 2a minus t, and dx means minus dt. So this minus we can bring here first, minus a to 0 f of 2a minus t dt. Now you can see that again we will use that property number p1. Interchange the limit. Interchange the limit. Interchange the limit. So it will be 0 to a, then minus minus plus f of 2a minus t dt. How? By using p1 properties. So see, now p1 is very important, p1 and p0. Okay, these properties we are using to prove any other properties. Now next, 0 to a f of 2a, and t we can write x because it is independent of variable. Okay, here also dx by using p0 properties. Now put this value in the equation number 1. This is the equation. Okay, you can see this equation 1. Put this value in equation 1, then we will get 0 to 2a fx dx equals to 0 to a fx dx plus this value become this value 0 to a f of 2a minus x dx. And can you see, yes, this is the proof of the p5 property. Okay, so we have proved this, hence proved. Next, see property number 7, which is p6 property. According to p6 property, this property says that limit 0 to 2a fx dx, it is twice of 0 to a fx dx. Okay, when f2a minus x is simple fx, and it is 0 when f2a minus x is minus fx. Okay, and this property we have used to prove that integral. Remember, 0 to pi by 2 log sin x dx. Okay, the very important integral of NCERT. If you have not seen, okay, I will put the link in I button, you can go and check. To prove this, we will take the help of this p5 property. Okay, p5. So according to p5, using p5, 0 to 2a fx dx, 0 to a fx dx plus 0 to a f of 2a minus x dx. Okay, this is according to p5. Now take the case when f of 2a minus x is fx, when f of 2a minus x is fx, then what you will get, 0 to 2a fx dx equals to 0 to a fx dx plus 0 to a, and f of 2a minus x is fx dx, and simple, it is nothing, it is twice 0 to a fx dx. Equation number 2. Second case, another, this, when f of 2a minus x is minus fx, then 0 to 2a fx dx would be 0 to a fx dx, 0 to a fx dx plus 0 to a, and f of 2a minus x becomes f minus x, minus fx becomes. So you can see this and this cancel, so we are getting 0. Now combine 2 and 3, we can write now this. Yes, 0 to 2a fx dx is nothing. So from 2 and 3, we can write 0 to 2a fx dx. Okay, it is twice 0 to a fx dx when f of 2a minus x is fx, and 0 when f of 2a minus x is minus fx. Okay, hence proved this property. Now last property. Okay, minus a to a fx dx is twice 0 to a fx dx when fx is even. Okay, and 0 when fx is odd. So this property we will prove in a separate video.